Have you ever gazed upon a starlit sky and felt a sense of wonder wash over you? The universe, in its vastness and mystery, has captivated humanity for millennia. Tonight we go on a journey, a soothing exploration of the cosmos. Let us drift along the currents of time and space back to the very beginning. Our destination, the origin of atoms, the building blocks of everything we see and feel. It's a story of incredible energy, elegant simplicity, and the birth of complexity from the void. As we journey, let the gentle cadence of our tale lull you into a state of tranquility. Imagine, if you will, a time before time, a place before space. This may seem like an impossible notion, yet it's the starting point of our universe's story. Relax your mind, release your worries, and allow yourself to be carried away on this cosmic lullaby. The birth of our universe, the Big Bang, is often described as an explosion, but it was not an explosion in the conventional sense. Instead, imagine an unfolding, an expansion from an infinitely small point, a singularity, into something infinitely larger. This wasn't a chaotic event, but rather an elegant, harmonious process. From this singularity, space itself began to expand. Imagine a balloon being inflated, its surface stretching outward. The universe wasn't expanding into anything, rather, space itself was being created. Within this nascent universe, energy, pure and potent, filled the void. This energy, in accordance with the laws of physics, could not remain static. It began to cool and transform, setting the stage for the formation of everything we know and cherish. As you visualize this cosmic dance, feel your own worries and stresses melt away, replaced by the tranquility of the early universe. The universe, in its infancy, was an incredibly hot and dense place. Imagine a furnace far hotter than anything we could create on Earth. As the universe expanded, it cooled, much like the air rushing out of an opened oven. This cooling process was crucial for the formation of matter. Out of this cooling energy, the fundamental building blocks of matter, quarks and leptons, began to emerge. These particles, infinitesimally small, would eventually combine to form the atoms that make up everything around us. The universe was beginning to speak a new language, the language of matter. These early moments of the universe were a symphony of energy and transformation. As you reflect on this cosmic ballet, allow yourself to drift further into a state of relaxation. The universe, in its infancy, was a place of constant change, yet it held within it the seeds of order and complexity. As the universe continued to cool, quarks, those fundamental particles, began to combine. They formed protons and neutrons, the building blocks of atomic nuclei. Imagine tiny magnets drawn together by an invisible force, forming the hearts of atoms. These protons and neutrons, bound together by the strong nuclear force, created a stable structure. This stability was crucial, as it allowed for the creation of elements, the ingredients for stars, planets, and even life itself. The universe was beginning to take on a more familiar form. These early atoms, primarily hydrogen and helium, were the first steps in a long evolutionary process. They would eventually clump together, drawn by gravity, to form the first stars and galaxies. The universe, once a sea of energy, was becoming a tapestry of matter. Section 5. The language of the cosmos. The formation of atoms marked a pivotal moment in the universe's history. It was the transition from a universe dominated by energy to one where matter could exist and interact in complex ways. Atoms became the letters in the universe's alphabet, capable of forming countless combinations. These combinations would eventually give rise to everything we see around us: the air we breathe, the water we drink, the earth beneath our feet. The universe was no longer a blank canvas, but a vibrant tapestry of elements, each with its own unique properties. As you ponder the significance of this transformation, allow yourself to feel a sense of awe and wonder. The universe, in its elegance and simplicity, had created the building blocks for complexity and life itself. Take a deep breath and appreciate the interconnectedness of all things. Section 6. The Dance of Time and Space. The story of atom formation is a tale of timescales that are difficult for the human mind to grasp. The universe, from its birth to the creation of the first atoms, unfolded over billions of years. It's a reminder of our own small place in the grand scheme of things. Yet within this vastness, there's a sense of comfort. The same laws of physics that governed the early universe are at work today, holding galaxies together, dictating the life cycles of stars, and even influencing the rhythm of our own bodies. As you reflect on the immense scales of time and space, allow yourself to feel a sense of peace and tranquility. The universe operates on its own timescale, a reminder to slow down, breathe, and appreciate the present moment. We are all part of this grand cosmic dance. Section 7. Our place in the cosmic tapestry. The formation of atoms is not just a scientific curiosity, it's the foundation of our very existence. The atoms that make up our bodies were forged in the hearts of stars, scattered across the cosmos in supernova explosions, and eventually coalesced into our planet and ourselves. We are, in a very real sense, stardust. The atoms that make up our bodies have witnessed the birth and death of stars, the formation of galaxies, and the vast expanse of cosmic time. It's a humbling thought, a reminder of our connection to the universe and everything in it. As we conclude our journey, let us carry with us a sense of wonder and appreciation for the universe and our place within it. The story of atom formation is a testament to the beauty, elegance, and interconnectedness of the cosmos. May this knowledge bring you peace and tranquility as you drift off to sleep. Picture, if you will, a darkness so profound, so absolute that it defies description, an emptiness so complete that it transcends our everyday understanding of nothingness. This, my friends, is the canvas upon which the universe's grand story will be painted. A story that begins not with a bang, as some might imagine, but with a spark. In the heart of this unimaginable void, a point of infinite density, smaller than the smallest atom, stirs to life. We call this point a singularity, a realm where our current understanding of physics breaks down, a place where the very fabric of space and time are woven together. This is not an explosion as we know it, no shrapnel or sound, but rather an expansion. Imagine a droplet of water, pregnant with possibility, about to bloom into a boundless ocean. It is from this singularity, this infinitesimal point of potential, that our universe bursts forth. The universe in its first moments is smaller than an atom. It's difficult to grasp, isn't it? Our minds struggle to comprehend such immensity contained within such a small space. Yet within this tiny realm, everything that ever was, is, and ever will be is present. Imagine, if you will, a seed containing within its shell the blueprint for a mighty oak. The universe at this stage is akin to that seed, holding within its infinitesimal form the potential for stars, galaxies, and even life itself. As we journey further into this nascent universe, allow your worries to melt away, replaced by a sense of wonder. Let the incomprehensible scale of creation wash over you, not with fear, but with awe. For in the grand tapestry of the cosmos, even the smallest thread plays a vital role. Time itself begins to unfold, not in minutes or seconds as we know them, but in infinitesimal fractions of a second. The universe, still unimaginably hot and dense, is a cauldron of pure energy, a place where the four fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, are unified. In these first fleeting moments, the universe expands at an astonishing rate, doubling in size every fraction of a second. This period, known as inflation, is a time of unimaginable turmoil, yet it lays the foundation for the universe as we know it. This is not a chaotic expansion, but a dance governed by the laws of physics. From the maelstrom of the early universe, order begins to emerge. As the universe expands and cools, the stage is set for the next act in this cosmic drama, the formation of matter. Imagine, if you can, a balloon being inflated, its surface stretching outwards at an incredible speed. This is akin to the expansion of the early universe. But here's the wonder. The universe isn't expanding into anything. Space itself is being created. The very fabric of space-time, the stage upon which the cosmos plays out its grand drama, is being woven into existence. It's a mind-boggling concept, isn't it? To think that everything we know, everything we see and touch, exists within this ever-expanding fabric of space and time. As the universe inflates, its temperature drops, much like the air rushing out of an opened oven. This cooling is crucial, for it allows energy to convert into matter, the building blocks of stars, planets, and ultimately ourselves. Within this rapidly expanding universe, the four fundamental forces of nature, once unified, begin to separate. Imagine a symphony orchestra tuning its instruments, each finding its own unique voice, yet harmonizing with the others to create a grand, unified sound. Gravity, the force that draws us to the Earth and holds galaxies together, emerges as the first distinct force. Electromagnetism, the force responsible for light, electricity, and magnetism, follows close behind. And finally, the strong and weak nuclear forces governing the interactions within the hearts of atoms complete the quartet. This separation of forces is a pivotal moment in the universe's evolution. It marks the transition from a state of pure energy to one where matter can begin to take shape. The stage is set for the next act in our cosmic drama, the emergence of particles. The universe, still a searing hot furnace, is awash in energy. Imagine a sea of light, a brilliant, blinding radiance, far more intense than anything we could ever experience. This energy, however, is not uniform. It fluctuates, creating tiny ripples and eddies in the fabric of space-time. These fluctuations, though seemingly insignificant, are crucial. They represent tiny differences in energy density, like seeds scattered across a cosmic field. It is from these seeds that matter, the building blocks of our universe, will eventually sprout. As you visualize this energetic dance, allow yourself to relax further. Let the sheer power and beauty of the early universe wash over you, not with fear, but with a sense of wonder. For even in the most chaotic of times, the universe is guided by an underlying order, a cosmic symphony playing out across the vast expanse of space and time. As the universe continues its rapid expansion, it begins to cool. Imagine a pot of boiling water taken off the stove, the heat gradually dissipating into the surrounding air. In a similar way, the energy of the early universe spreads out, its intensity diminishing as space itself expands. This cooling process is crucial for the formation of matter. Just as water vapor condenses into droplets as the air cools, so too does the energy of the early universe begin to condense into particles. These particles, the building blocks of atoms, are the first hints of the material world we know and love. As you visualize this cosmic cooling, allow yourself to drift further into a state of tranquility. The universe in its infancy was a place of intense heat and energy. Yet through the elegant dance of expansion and cooling, it began to create the conditions necessary for the emergence of complexity and life itself. The universe, though still in its infancy, is undergoing a profound transformation. From the chaotic soup of energy, the first particles of matter begin to emerge. These particles, quarks and leptons, are the fundamental building blocks of atoms, the very essence of the material world. Imagine a sculptor starting with a shapeless block of clay. With each deft movement of their hands, they mold and shape the clay, gradually bringing form and definition to what was once formless. In a similar way, the universe, through the cooling and expansion, begins to shape the raw energy into particles, laying the foundation for the intricate structures of matter. These particles, though infinitesimally small, are teeming with potential. They will soon combine and interact, guided by the fundamental forces of nature, to form the protons, neutrons, and electrons that make up atoms. The universe is transitioning from a realm of pure energy to one where matter will soon reign supreme. Imagine, if you will, a warm bath, the steam rising gently, enveloping you in a comforting embrace. The early universe, though still incredibly hot by our standards, is cooling down, its energy spreading out as space itself expands. This cooling is not a sudden chill, but a gradual, gentle process, like the slow fading of summer's heat into the crispness of autumn. As the universe cools, it crosses a crucial threshold. The energy that once permeated every corner of existence begins to condense, transforming from its ethereal form into something more tangible, more substantial. It is from this cooling energy that the building blocks of matter, the particles that make up everything we see and touch, will emerge. Just as a sculptor begins with a shapeless block of clay, so too does the universe begin with a sea of raw energy. The cooling process acts as the sculptor's hands, gradually molding and shaping the energy, coaxing it into new and intricate forms. And from this cosmic sculpting, the first particles of matter will soon arise. The universe, now a billionth of a second old, is a whirlwind of activity. Within its rapidly expanding expanse, energy continues to condense, giving birth to a kaleidoscope of particles. These particles, far smaller than atoms, are the fundamental building blocks of matter, the very essence of our material world. Among the first particles to appear are quarks and leptons, the tiniest constituents of matter known to science. Imagine them as tiny, swirling points of energy, each carrying within it the potential for something greater. Quarks, the building blocks of protons and neutrons, are inherently social particles, destined to bind together in trios. Leptons, on the other hand, are more solitary, existing as individuals or forming pairs. Like dancers in a grand cosmic ballet, quarks and leptons twirl and interact, drawn together and pushed apart by the fundamental forces of nature. Their interactions, governed by the laws of physics, are the first steps in a long and intricate dance that will eventually give rise to the complexity of the universe we inhabit. The early universe, once a homogeneous sea of energy, is now a bustling metropolis of particles. Quarks and leptons, those fundamental building blocks of matter, zip and collide, their interactions creating a cosmic symphony of creation and annihilation. The universe in its infancy is a dynamic, ever-changing realm, a far cry from the relatively stable cosmos we observe today. Imagine, if you can, a snow globe, its tiny flakes swirling and colliding within their confined space. The early universe, though vastly larger, is similarly filled with a flurry of activity. Particles are constantly being created and destroyed, their fleeting existence a testament to the raw energy that still permeates the cosmos. Yet amidst this chaotic dance, a sense of order begins to emerge. As the universe continues to expand and cool, the rate of particle creation slows, while the forces that govern their interactions begin to assert their dominance. The stage is set for the next act in this cosmic drama, the formation of protons and neutrons. As the universe cools, a fundamental force of nature begins to assert its dominance, the strong force. Imagine, if you will, a group of magnets, their opposing poles pushing them apart. The strong force acts in a similar way, but on a much smaller scale, binding together quarks, those tiny particles we met earlier. The strong force is aptly named, for it is the most powerful of the four fundamental forces. It acts over extremely short distances, holding quarks together with an unbreakable grip. Without the strong force, quarks would exist only as solitary entities, unable to form the protons and neutrons that lie at the heart of every atom. The emergence of the strong force marks a pivotal moment in the universe's evolution. It is the force that will allow matter in the form of protons and neutrons to become stable and enduring. The universe, once a sea of fleeting particles, is now poised to create the building blocks of a more permanent reality. Protons and neutrons take shape. In the early universe, a remarkable transformation occurs. Quarks clump together, forming trios. These trios are protons and neutrons, the heart of every atom. The formation of protons and neutrons is crucial for complexity. Section 6. A universe teeming with nuclei. The universe, now a few minutes old, is a bustling nursery of protons and neutrons. These particles, forged in the intense heat and pressure of the early universe, zip and collide, their interactions governed by the strong force and a new player on the cosmic stage, the weak force. The weak force, though less powerful than its strong counterpart, plays a crucial role in shaping the early universe. It governs certain types of radioactive decay, allowing protons and neutrons to transform into each other, establishing a delicate balance between these two fundamental particles. Imagine, if you can, a bustling city, its streets teeming with pedestrians moving to and fro, their paths intersecting and diverging. The early universe, though vastly larger, is similarly filled with a flurry of activity as protons and neutrons collide, interact, and occasionally transform into each other. Section 7. The era of nucleosynthesis. The universe, still young and incredibly hot, enters a period known as nucleosynthesis. During this crucial epoch, protons and neutrons, those building blocks of atomic nuclei, begin to fuse together, creating the first light elements: hydrogen, helium, and trace amounts of lithium. Imagine, if you will, a campfire, its flames dancing and swirling, fusing small pieces of wood into larger embers. In a similar way, the intense heat and pressure of the early universe act as a cosmic furnace, fusing protons and neutrons together to create the nuclei of the first elements. This process of nuclear fusion releases tremendous amounts of energy, bathing the universe in a brilliant afterglow that astronomers can still detect today. This afterglow, known as the cosmic microwave background radiation, is a faint echo of the Big Bang, a testament to the universe's fiery beginnings. As the universe continues to expand and cool, the era of nucleosynthesis gradually draws to a close. The cauldron of the early universe, once a raging inferno of nuclear fusion, begins to simmer down, leaving behind a cosmos enriched with the first light elements. These elements, primarily hydrogen and helium, the simplest and most abundant elements in the universe, will serve as the raw ingredients for the formation of stars, galaxies, and all the celestial wonders we marvel at today. Like seeds scattered across a vast cosmic field, these primordial elements hold within them the potential for future growth and complexity. The universe, once a sea of undifferentiated energy, has now given birth to the building blocks of a more structured reality. The stage is set for the next act in this grand cosmic drama, the formation of stars and galaxies, those luminous beacons that illuminate the vast expanse of space. The early universe, once a chaotic sea of energy and particles, has undergone a remarkable transformation. Through the elegant interplay of expansion, cooling, and the fundamental forces of nature, it has created the first atoms, those building blocks of our material world. These atoms, primarily hydrogen and helium, are now scattered across the expanding cosmos, forming a vast, diffuse cloud of gas. Gravity, that ever-present force, begins to exert its subtle influence, drawing these atoms together, setting in motion a chain of events that will shape the universe as we know it. The universe, though still in its infancy, is now primed for complexity. Within the swirling clouds of hydrogen and helium, stars will ignite, galaxies will take shape, and planets will coalesce around newborn suns. The stage is set for the emergence of life itself, a testament to the universe's remarkable ability to transform simplicity into awe-inspiring complexity. The universe, still young and vibrant, continues to cool. As its energy dissipates into the ever-expanding fabric of space, a remarkable transformation begins. The protons and neutrons, those tiny bundles of energy nestled within the heart of atoms, find themselves drawn to the universe's coolest pockets. Imagine, if you will, a ballroom filled with dancers swirling and twirling to a cosmic melody. These dancers, our protons and neutrons, are not alone. Buzzing around them like fireflies on a warm summer night are electrons, tiny particles with a negative charge. These electrons, much lighter than their proton and neutron counterparts, flit about in a frenzy of motion. They are drawn to the positively charged protons, but their energetic dance keeps them from settling down just yet. The universe at this stage is a whirlwind of attraction and motion, a delicate ballet of particles finding their place in the grand scheme of things. As the universe cools, the frenetic dance of electrons slows. Electrons settle into stable orbits around protons and neutrons. These clusters form the first true atoms, the building blocks of our world. Electrons find solace and stability in the embrace of protons. The universe transitions from chaos to a more ordered state. Before the capture of electrons, the universe was a sea of ions, atoms with a net electrical charge. This period, known as the era of recombination, marks a profound shift. As electrons settle into their orbits, the universe transforms from chaos to tranquility. The universe, once opaque to light, begins to become transparent. Light is now free to travel unimpeded, carrying the secrets of the early universe. The universe, once a prisoner of its own opacity, experiences a moment of liberation. Light, that ethereal messenger, is finally free to travel unimpeded across the cosmos. The universe becomes transparent, and the first light begins its long journey through space and time. Imagine a dense fog lifting, revealing a breathtaking landscape. As atoms capture electrons, the fog lifts and the universe is bathed in the warm glow of its first light. Atoms take center stage in the cosmic drama. They become the protagonists in the universe's grand narrative. The stage is set for the formation of stars, galaxies, and celestial wonders. Imagine a spotlight, revealing actors frozen in anticipation. The spotlight represents the universe's transparency after recombination. The actors are the atoms, poised to play their roles in the cosmos. In the vast expanse of the cosmos, a subtle force begins to exert its influence. Gravity, that universal attractor, acts as a cosmic sculptor, gently nudging the newly formed atoms, drawing them together into ever larger clouds of gas. These clouds, vast reservoirs of hydrogen and helium, are the birthplaces of stars, the furnaces where heavier elements will be forged. Imagine, if you will, a gentle breeze blowing across a field of wildflowers, their delicate petals swaying in unison. Gravity, in our cosmic garden, acts as that breeze, its influence subtle yet persistent, guiding the distribution of matter and shaping the large-scale structure of the universe. Within these vast clouds of gas, gravity draws atoms closer and closer together, increasing their density and temperature. As the clouds contract, they begin to spin, like a figure skater pulling in their arms during a graceful pirouette. This spin amplifies the effects of gravity, further accelerating the collapse of the cloud and setting the stage for the dramatic birth of stars. Within the fiery hearts of stars, a remarkable alchemy is taking place. The intense heat and pressure generated by gravity's relentless pull fuse hydrogen atoms together, creating helium and releasing enormous amounts of energy. This process, known as nuclear fusion, is the engine that powers stars, flooding the universe with light and heat. Imagine, if you will, a grand symphony orchestra, each instrument playing its part to create a harmonious whole. Within a star, the fundamental forces of nature play the role of musicians, their interactions orchestrating the fusion of atoms and the creation of new elements. But stars are not content with simply fusing hydrogen into helium. As they age and their cores become denser and hotter, they begin to fuse heavier elements, creating carbon, oxygen, nitrogen, and all the elements that make up the world around us. Stars, in a sense, are cosmic alchemists, transforming the light elements forged in the Big Bang into the rich diversity of elements we observe today. As stars exhaust their nuclear fuel, they reach the end of their lives, expelling their outer layers into space in spectacular supernova explosions. These explosions seed the universe with heavier elements forged in the hearts of stars. These elements become new stars, planets, and even life itself. Imagine a dandelion, its seeds spreading to create new life. Supernova explosions play a similar role, dispersing the building blocks of life. The atoms that make up our bodies were forged in the hearts of stars. We are stardust, a testament to the cosmos. The universe has created the conditions necessary for life, for us to ponder our place in the grand scheme of things. Remember that diffuse cloud of atoms scattered across the universe after the Big Bang? Gravity, patient and persistent, never stopped working its magic. Over eons, it drew those atoms together, not uniformly, but in a delicate dance, forming a vast, intricate structure we call the cosmic web. Imagine a spider web, glistening with morning dew, stretching across a garden. The cosmic web is similar, but on a scale that boggles the mind. Filaments of dark matter, invisible to our eyes, form the web's backbone, pulling in those primordial atoms, hydrogen and helium, along its strands. At the web's intersections, where gravity's pull is strongest, those clouds of atoms clump together, forming massive structures. These are the seeds of galaxies, the homes of billions upon billions of stars yet to be born. And our Milky Way, the majestic spiral galaxy we call home, resides within one such cosmic filament, a tiny part of this grand, interconnected tapestry. Within those massive clumps of gas, drawn together by gravity's relentless pull, a beautiful chaos reigns. Clouds of hydrogen and helium collide, their atoms jostling and compressing, temperatures rising with each interaction. These are the stellar nurseries, the wombs of stars where the universe ignites with new light. Imagine a bustling city, its streets teeming with life, energy crackling in the air. Within those stellar nurseries, a similar energy pervades, a cosmic dance of creation. As gravity pulls tighter, those compressed clouds of gas reach a critical point. The pressure ignites nuclear fusion, hydrogen atoms smashing together to form helium, releasing a burst of energy, and a star is born. These newborn stars, clustered together, exert their own gravitational pull, influencing the surrounding gas and dust. Over time, this dance of gravity and starlight shapes those chaotic clouds into the majestic spiral arms of galaxies, our own Milky Way, a stunning example of this cosmic choreography. Stars, however, are not solitary creatures. As they form within those swirling clouds of gas and dust, some of that material remains, orbiting the newborn star in a swirling disk. This protoplanetary disk, a chaotic jumble of leftover ingredients, is where planets, those smaller companions to stars, will eventually emerge. Imagine a potter at their wheel, shaping clay with deft fingers. Gravity acts as the potter, its invisible hand guiding the material in those disks, drawing particles together, building them up over time. Dust grains clump together, forming larger and larger aggregates, their gravity attracting more material, slowly but surely growing into planetesimals. These planetesimals, the seeds of planets, continue to collide and merge, their orbits gradually settling into a more stable configuration. Over millions of years, this process of accretion builds up planets of various sizes and compositions, some rocky like our own Earth, others gaseous giants like Jupiter and Saturn. Within those swirling protoplanetary disks, something truly remarkable is happening. The atoms, forged in the hearts of long-dead stars, are not just forming planets. They're assembling into the building blocks of life itself. Carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. These elements, forged in the crucibles of stars, are the essential ingredients for life as we know it. Imagine a chef combining simple ingredients, flour, water, yeast, to create a delicious loaf of bread. The universe in its own grand kitchen is doing something similar. Within those protoplanetary disks, those key elements, brought together by chance and circumstance, begin to interact. They form complex molecules, organic molecules, the precursors to life. Water ice, laden with those essential elements delivered to young planets by comets and asteroids, further enriches those planetary surfaces, setting the stage for life's grand experiment to begin. On our own planet, Earth, bathed in the warmth of the sun, those building blocks of life took an extraordinary leap. Within the primordial soup of early oceans, those organic molecules, constantly jostling and interacting, assembled into even more complex structures. Imagine a delicate mobile, its elements in constant motion, yet perfectly balanced. Life, in many ways, is similar. Atoms, once forged in the hearts of stars, now dance to the rhythm of life, constantly moving, reacting, forming and breaking bonds, yet maintaining a delicate equilibrium. From single-celled organisms to complex plants and animals, life is a testament to the universe's ability to organize matter into intricate and beautiful forms. And every breath we take, every beat of our hearts, is a reminder that we are a part of this grand cosmic cycle, our atoms forever intertwined with the universe that created us. The story of the universe, from the Big Bang to the formation of planets and the emergence of life, is a story of endless wonder and awe-inspiring beauty. It's a story that unfolds over billions of years, a story written in the language of stars, galaxies, and the very atoms that make up our bodies. Imagine yourself standing under a clear night sky, the Milky Way arching overhead, a dazzling tapestry of starlight. Each of those points of light, a sun, perhaps orbited by planets of its own. And on some of those planets, who knows what wonders might exist? The universe is vast, far beyond our ability to fully comprehend. Yet within its immensity, there's a sense of peace, a reminder that we are part of something far greater than ourselves. Our own existence, a fleeting moment in the grand scheme of things, is no less miraculous for its brevity. We are, after all, children of the cosmos, born of stardust, and that is a truly humbling thought. As we gaze upon the night sky, we are, in essence, looking back in time. The light from distant stars, some long gone, has traveled for millions, even billions of years to reach our eyes. We are witnesses to the universe's grand history, a history written in the language of light and gravity, a history that connects us to every star, every galaxy, every atom in the cosmos. Imagine holding a fossil in your hand, feeling the weight of millions of years of history. When we study the universe, we are engaging in a similar act of cosmic archaeology, piecing together the story of our origins, tracing our lineage back to the Big Bang itself. Our understanding of the universe is constantly evolving. New discoveries, challenging old assumptions, pushing the boundaries of our knowledge. Yet, with each new revelation, our sense of awe and wonder only deepens. We are, after all, a species driven by curiosity, a species that yearns to understand its place in the grand tapestry of the cosmos. The atoms that make up our bodies, once forged in the hearts of stars, will continue their cosmic journey long after we are gone. They may become part of new stars, new planets, new life forms yet to exist. Our own existence, though finite, is part of a continuous cycle of cosmic creation and destruction, a cycle that ensures the universe will continue to evolve, to change, to amaze us for eons to come. Imagine a single drop of water falling into a vast ocean, merging with the infinite. Our lives, in the grand scheme of the cosmos, may seem equally small. Yet, like that drop of water, we are a part of something vast and enduring. The universe, in its infinite wisdom, has gifted us with consciousness, with the ability to appreciate its beauty, to unravel its mysteries, to marvel at its grandeur. Let us then cherish this gift, this cosmic inheritance, and strive to live lives worthy of the extraordinary universe that created us. As we conclude our journey to the dawn of time, let's appreciate the profound implications of what we've discovered. Those atoms forged in the Big Bang's fiery furnace are not just out there, they're within us. Place your hand over your heart. Feel the warmth of your skin, the gentle rhythm of your breath. Every cell, every molecule, every atom within you has a history that stretches back to the universe's earliest moments. The iron in your blood, the calcium in your bones, the oxygen that fills your lungs, all were created in the hearts of stars. We are, in a very real sense, stardust, walking, talking testaments to the universe's extraordinary journey. Close your eyes and take a deep breath. Feel the air fill your lungs, that life-giving oxygen coursing through your body. Those atoms were once part of the swirling chaos of the early universe. They were present when the first stars ignited, flooding the cosmos with light. Each breath connects us to that grand cosmic narrative. We are an integral part of the universe's ongoing evolution. The universe, for all its vastness and complexity, is governed by a remarkably consistent set of rules, the laws of physics. These laws, constant across space and time, dictate the interactions of atoms, the birth and death of stars, the dance of galaxies, and even the rhythm of our own hearts. In a world that often feels chaotic and unpredictable, the constancy of the universe can be a source of profound comfort. The same gravity that holds the moon in orbit around Earth also guides the planets around our sun and binds galaxies together across unimaginable distances. The same electromagnetic force that lights our homes also powers the stars and paints the aurora borealis across the night sky. These cosmic constants remind us that we are part of a grand interconnected system, a universe governed by order and elegance. Even amidst the uncertainties of life, we can find solace in the knowledge that the universe, in its fundamental workings, is a place of unwavering consistency. As we've journeyed through the universe's history, from the Big Bang to the formation of atoms and the emergence of life, our perspective has inevitably shifted. We've zoomed out from the familiar scale of our everyday lives to embrace a cosmic viewpoint, one that encompasses billions of years and trillions of stars. This cosmic perspective can be both humbling and empowering. It reminds us that our individual worries are but fleeting moments in the vastness of time and space. Our journey through the universe's origins has reached its end, for now. We've explored the Big Bang's fiery birth, witnessed the formation of atoms, and traced their journey to become the building blocks of stars, planets, and even ourselves. As you prepare for sleep, carry with you the wonder and awe inspired by our cosmic exploration. Imagine yourself drifting through space, the Earth a distant, swirling blue marble below. Above you, a canopy of stars, each a distant sun, perhaps harboring planets of its own. The universe stretches out before you, an endless frontier of mystery and beauty, a constant reminder of the boundless possibilities that exist within the fabric of reality. Let the gentle rhythm of your breath synchronize with the universe's heartbeat, the steady pulse of creation that has echoed through the cosmos for billions of years. As you close your eyes, surrender to the tranquility of the night sky, knowing that you are a part of something vast, ancient, and infinitely wondrous. As you drift off to sleep, let the universe lull you into a peaceful slumber. Imagine the gentle hum of the cosmos, a symphony of starlight and cosmic background radiation, a lullaby sung by the universe itself. Let go of any lingering thoughts or worries, allowing the vastness of space and the depth of time to cradle you in their embrace. Dream of swirling galaxies and distant nebulas, of planets yet to be discovered and life forms beyond our wildest imaginations. Let your mind wander among the stars, exploring the infinite possibilities that await us in the cosmic ocean. And when you wake, carry with you the tranquility of the cosmos, the knowledge that you are a part of something far greater than yourself. Embrace the day with a renewed sense of wonder, a deeper appreciation for the interconnectedness of all things, and the understanding that even in the darkest of nights, the universe always shines bright. Sweet dreams from the universe